All right. Okay. Now recording has started. Okay. So for this week, we will cover still on behavioral modeling. Okay, but part number 2, right? Okay. So part number 3 is on FSM, finite state machines. So part number 2, just elaboration of what we have done last week lah. Basically on continuous assignment, single pass behavior, and also cyclic behavior. So these 3 types of behavioral model, so we have discussed already. So for example, untuk continuous assignment, so the keyword for continuous assignment is assign. You remember, okay? Assign, for example, y equal to a and b, for example. This, okay? Even in your lab number 0, we have discussed this. Okay, so that's about continuous assignment. So the word continuous, the word continuous here means that y always continuously assign the value of a and b. Okay, so we continuously get the value of operation between a and b. Okay, so no memory element for this type of behavioral model. So it will continuously assign, like you use a multimeter probe, you put on the resistor, for example, and then you measure the resistance value, okay, or the current value, for example, and then the value keep changes, and then you will not have a memory element to memorize the previous element. So that's actually basically a continuous assignment, and that's why in this case y, this is y, is wire data type. It's not a register data type. It must be a wire data type. When you put the design, so y has to be a wire data type, a register, because continuous signal or continuous assignment, y has to be a data type. That's the rule, right? And then we also discuss about single pass behavior. Okay, single pass behavior, keyword for single pass behavior is initial. So you mostly you use in a test bench. Okay, initial, and then you have you give the input, and then the input will not repeat. Okay, it's only given once only until the end of the block, and then it will not repeat. So that's actually single pass behavior. Okay. And then we also have cyclic behavior. So cyclic behavior, the keyword is always at something lah. It's either level sensitive or age sensitive. Okay. So this one A or B, for example. So this is actually level sensitive, and you also can use for age sensitive. Always at post H CLK, for example. So this is age sensitive. This is level sensitive. Level sensitive. This one is age sensitive. These 2 types kita guna untuk represent cyclic behavior. So depending on the design. Okay, for example, you are designing a counter. Okay, normally untuk counter kita gunakan age sensitive, shift register, all type of sequential circuit lah. We use age sensitive, either post age or negative age. Okay, remember we have discussed, I think, detail about this one. So we have about this one. This is our clock, and the rising one we call as rising age or post age, and the falling we call as negative age or falling age. Okay. About the level, okay, level sensitive means that it's either high or low. Okay, so for example, you have some design like this one. So always at H CLK, and then Q equal to B. What is this? What is the equivalent hardware for this one? Ini kita buat apa ni? Q equal to D. Apa boleh jawab? Apa hardware-nya ataupun equivalent hardware for this code? equivalent component or equivalent circuits for this one. Any? Boleh cuba, salah, okay, no problem. Sekurang-kurangnya saya boleh kenal, okay. Tadi Ikmal kan, okay. Any other, any try from you all? Okay, good. Dengan suara nah. Okay, so this is actually flip-flop. So how about we remove this. So this one become what? Any try? This is flip-flop lah, betul? So this is flip-flop. Maybe we use different color. Flip-flop. Okay, flip-flop circuit. Okay, and this one is actually latch. Okay, latch. Right, we have unwanted latch and also latch that required in the design. Okay, so in this case, let's say we want to have to design a latch. This is actually the way we write the code. Okay, always add clock. Means that high level of the clock, every high level of the clock, Q equal to D. In this case, every rising edge of the clock, which means that during this, we will update Q with D. Okay. So both actually has memory element, means that Q need to be a register data type because it's inside the always block. But in terms of output, it will be different. Why is different? Because one is actually level sensitive and the other one is edge sensitive, right? So edge sensitive means that Q value remain its previous value until the next rising edge of the clock. Okay, you get the point. Huh? So, for example, okay, we have a clock like this one. This is the clock. Okay, tak berapa cantik sikit clock saya. Okay, this is clock and this is, for example, D. Or maybe we use a single line first, single one bit first. And this is, for example, B. Okay. Okay. And what is actually the equivalent Q? So Q is actually will be depends on the rising edge of the clock. This first and this second. So we evaluate during the first rising edge. So this is 0. So Q will become 0 until the next rising edge of clock. So which means that until this one. So it will not follow this one because of the we only focus on the rising edge of the clock or positive edge of the clock. So during the positive edge of the clock, and then baru you get the high because this is high. The D is high here. Okay, so this is D. This is Q, and this is clock. C, CLK. I use. Okay. Yeah. How about latch? The latch, as I mentioned just now. Okay. So this, let's say we label as Q, and this one like Q prime, for example. So Q prime, maybe I need to move these three. Oh, cannot move. Okay, okay. So let's say we use different color, right? So for latch, it's only sensitive on every rising, every high level of the clock. So during the high level of the clock, we will get the value of D. In this case, it will copy this until this. So Q prime is actually until we make the line first. Okay, so we will copy the previous value until here, and then it will continue the previous value until the next Okay, and then here it will copy this. Okay, now you see, dash is different compared to the okay, compared to the flip-flop. Okay, it follow until the next then baru. Okay, different latch and also flip-flop. So this Q bar, Q bar or Q prime lah. Okay, right. This one is actually Q. Q. Okay, that's actually about the modeling. Right, now we continue to the flow concept in very long. I think this is also we have discussed. Okay, concurrent means that parallel. Sequential means that one after another. Okay, the execution is one after another. So flow here means that the operation or the execution inside the our code or our module. Okay, and we have also a control flow. Okay, in the behavioral model, and we also have discussed if F and also case statement. Okay. All right. This you can read by your own. So this one already discussed. Continuous assignment, the keyword is assign. Single path behavior, the keyword is initial. Cycling is always. Okay. These are the and if you go here, okay, behavioral model. So remember, we can model using 3 different model. Okay, assign, always, and initial. So behavioral model can be used to model combinational logic, okay, like your lab number 0, your AND gate, OR gate, and all the multiplexers and so on to combinational logic, right? You can also use the behavioral model to model sequential logic. Okay, I mentioned just now, level sensitive or edge sensitive, right? So for example, the flip-flop here and also the latch here. So we can use the always block. Normally we use always block for edge sensitive and level sensitive. All right, so both are sequential logic. And we can also use the behavioral model to represent finite state machine. So this is actually will be covered in FSM, chapter FSM. Jadi kita akan cover dalam chapter FSM. So from now on, bila saya sebut saja behavioral model, you dah sepatutnya boleh imagine cyclic behavior, initial, and also continuous assignment. Okay, single path behavior and also continuous assignment. Kita discuss. Okay, so that's actually a model we can use to represent any of the logic circuits. In terms of activity flow, okay, this you can read on your own. As I mentioned to you, concurrency means that we execute at the same time, while sequential we execute one instruction at a time. Okay. That's actually the definition. And in terms of example, so we can see clearly here, boleh nampak di sini kita ada satu module, okay, and we have multiple always block here. Sini adalah contoh example of concurrent. Maksudnya execution of these 3 block happen at the same time. Okay. Contoh di sini bila I think kita ada contoh. We have example I think. Yeah. So example this one. So we have 2 always block here. Okay. 2 always block here. So in this case, you will get the value of Y, okay, and the value of Z concurrently or in parallel ataupun serentak you akan dapat. So that's actually concurrent, okay, what we call as concurrent. And sequential means that we either execution inside each of the always block tu ataupun macam ni. Okay, you ada assign Y equal to 0 equal to ini and so on. Ini maksudnya kita do di what we call sequentially lah, one after another. Okay. Dan bila you tengok contoh kat atas ni, ini pun salah satu sequential statement. Okay, sequential statement. Maksudnya, walaupun you ada always block, tapi ini ada satu saja always block. Disebabkan you menggunakan control flow-nya sekarang adalah if-else. So we can use if-else ataupun case. So the control flow sekarang ni adalah if. So maksudnya dia akan execute this one first. If A, maksudnya if A equal to 1. Remember, if A equal to 1, okay, so dia akan execute Y equal to 1. Else, if A not equal to B, then Y equal to 0. Means that it will check number this first, okay, if A equal to 1. So once this one fulfill, and then it will do the next line. Otherwise, it will do the Y equal to 0. So the execution of this, what we call signal assignment, okay, of this assignment, okay, dia berlaku secara sequential, one after another, ataupun one at a time. Okay, compared to yang tadi. This is actually example lah. So let's say if I ask you differentiate or demonstrate, okay, with the aid of suitable Verilog code, demonstrate, okay, concurrency and sequential in Verilog or in the activity flow. So you can use that as an example. Boleh guna sebagai contoh. Okay, alright. Contoh macam ni. So you boleh juga diminta untuk predict the output of Y0 of Y. Okay. So in this case, nampak kan, Y ni adalah 3 bit. So means that kita ada 3 bit. Okay. Bit 3, bit 2, dan bit 1 lah. So 0, 1, 2. Okay. So Y2 adalah ini. So you do operation ni and then you store here. And you do operation ni, then you store here. And you do operation ni, you store kat sini. So Y, eventually you will get the value of Y. Right? So this actually example yang mungkin you boleh do prediction. So let's say for example, A equal to 1, B equal to 0, C equal to whatever lah. And then you do the operation. Okay. Ini adalah O operation hingga N operation, and ini adalah multiple operation, and then you will get the respective value. Okay, and then you should be able to predict the output lah. Okay, boleh juga prediction tu in the form of timing diagram, macam mana you buat lab tu. Okay, cuba fahamkan balik timing diagram yang you buat tu dan juga lecture belum. Alright, so activity flow control. So we also have discussed this before about case statement. Okay. And also if-else statement. And we also have discussed a bit on for and also forever. So forever ni normally kita gunakan untuk generate clock. Okay, you nak generate clock ni dalam test bench. Kalau you nak make sure macam mana you nak make sure clock tu repetitively like this pattern. So normally kita buat satu portion saja. Contoh portion ni saja. Okay, so ini you initiate. So CLK equal to 0. Okay, CLK equal to 0, and then you kata forever, okay, how long the duration, for example every 5 time unit. So CLK equal to inverted CLK. So maksudnya apa dia? The initial value, oh sorry, okay, so maksudnya clock you sekarang ni kosong. Okay, you set kosong, and then you akan repeat the pattern. Okay, contoh kalau clock tu 1, dia akan jadi macam ni. So start from high, okay, start from high, and then low, and then high again, and continue lah. Okay, so because of the initial value tu kita set adalah 1. Okay, adalah 1, so dia akan jadi sini 1, so dia akan start dengan CLK1 kan, so dia start dengan macam ni lah, 1 then 0, so this is your clock, and the duration is, you tengok balik di sini, the clock period is actually 10 time unit lah. Okay, 10 time unit. Why 10? Because of kita set sini 5. Maksudnya dia invert setiap kali 5 time unit. So high, and then dia invert jadi low. So complete cycle of the clock, and then total 10. Right. Okay, so for for loop ni, actually if you go to lab 0, not lab 0 in your lecture, sorry, call it room. Lecture not on, I think test bench. Okay, we go to, oh no, classroom, e-learning. Okay, lecture not on simulation, test bench. Okay, here, you tengok dekat okay. Boleh tengok dekat sini, sekejap. Any question sebelum sementara menunggu ni? Kalau ada soalan boleh stop. Okay. You tengok dekat test bench type number, I think number 1. Yeah, here. Style number 1, so we have the for loop. This is how you use the for loop. So ini single pass behavior macam saya mention tadi, inilah for loop. Okay. For here. Okay. And then case and if else also we have discussed in our previous lecture. Alright. So normally if else tu kita gunakan untuk nak generate something that has a priority lah. So macam contoh macam tadi, if A macam ni, ada priority dah. Maksudnya you kena check A first. If A, do this. If A is not equal to B, and then do this. Maksudnya you check priority. That's what we call as priority lah. Right? Then example also here lah. So you will check this. If A and B, maksudnya kalau A and B ni equal to 1, itu maksud dia. Kalau A and B equal to 1. If A and C equal to 1, and so on. So ini gate N, ini pun gate N. Maksudnya kalau ini 1, 1 lah, dapat 1 kan. 1, 1. Okay, kalau dia punya single value to 1, and then they do the version. Maksudnya, in this case, we use if else. We don't use case statement because we want to have a priority. You check this first, and then you check the next one. And then we'll check the following or the others. That's what we call as priority. Okay, can you spot the output and also the input? So now, tadi nak tengok input atau output. Kalau kat semua dalam sensitivity list ni adalah input. These are the input. Okay, and the output is actually Y and Z. So Y and Z register or wire data type? Y and Z ni register ataupun wire? Siapa boleh jawab? Register ataupun wire data type. Ni not a complete mode, code lah. Kalau complete code you kena declare dekat atas kan. So Y and Z register or wire? Yes, it should be register. Thank you, Daniel. So it has to be registered. So inside the if else, okay, we also have a issue of incomplete if else statement, as I mentioned in the class lah. So when it happen, so normally we not specify all the possible combination of the input lah. Okay, with, for example, in this case, okay, if without else, okay, but this case specify on condition sebab you have A ni 1 1, ni 1 1, ni 1 0, ni nampak ni tu kalau ni 0 1, ni 0 0. Sebenarnya dia specify all the possible, okay, all possible condition of the input are specified. So in this case, okay, so another condition is if else without incomplete lah. So maksudnya ini 1 1, ini 1 0. So you have the remaining value of 0 0 and 0 1. So you not cover here. You hanya letak else is and then you tinggal there. So in this case, latch will be inferred. This is what we call as unwanted latch lah. Okay, unwanted latch. So unwanted latch ni akan menyebabkan you punya design akan jadi besar bandingkan design kawan-kawan. Okay, unwanted latch. Please be careful on this lah to avoid this kind of issue, normally kita letak satu lagi kat sini else y equal to 0 or whatever lah. Right? So ni not all possible input are covered or specified. Input yang ni tak di specify. So that's actually give you unwanted latches ataupun latch yang tidak diperlukan dalam design, yang mana boleh menyebabkan you punya area of your chip tu akan jadi lebih besar daripada yang sepatutnya. So if verilog code is written in if statement without all possibilities being specified, a latch will be inferred, unwanted latch lah. So this is undesirable since it would create unnecessary logic usage as I mentioned. Okay. So solution ni kita letak else to specify possible condition. So ni you boleh buat lah. Bila you ada free time, you try buat. Okay. Write a verilog code using conditional if else without latch inference to represent the function of the table. Ini adalah dia punya truth table dia. So A and B and C is the input, Y is the output. So you use the if else. Macam mana you nak represent. Okay. Lebih kurang sama macam yang atas ni lah sebenarnya. Okay, kalau kita tengok balik yang atas ni, lebih kurang sama macam ni. Okay, cuma you ada 3 lah. Ini ada 2 ya kan? Jadi ada 3 combination of input. So if A and B and so on. Tengok juga dia punya gate dia kan. So maksudnya ini adalah gate apa? Siapa boleh beritahu ni gate apa? Ya. Gate apa ni? Apa hardware dah? Apa circuit yang dia buat?
AND gate.
AND lah, betul lah. Ikmal kata AND, betul lah. Kalau AND gate dia mesti semua input satu baru dia jadi satu, betul lah. So sekarang ni salah satu input satu pun dia jadi satu, nampak tak? So ini mungkin lah. Ya mungkin gate ya. Thank you. Right? Ataupun mungkin boleh jadi combinational logic lah, logic gate yang boleh combine macam-macam. Okay, tapi saya rasa ni macam dah tengok balik lah, sebab bila you tengok sini semua satu, sini kosong, nampak tak? Okay. Kena check balik you punya digit 2. Right? Okay, so alternative to if else, okay, we can also use continuous assignment. So we also discuss this, and then we also discuss about the case statement. So to avoid unwanted latches, kalau if else tadi kena guna else. Kalau dalam kalau dalam case statement kena gunakan default. That's why bila you tengok dekat case statement you ada default. Contoh macam ni, ada default. Okay. But the default statement here is actually optional because you dah cover semua possibility of the input selector, because selector ni 2 bit, so dia akan jadi 00, 01, 10 and 11 lah. So equivalent di sini adalah 0, 1, 2, 3, which is kat sini lah, dia dah cover dah. Okay, so default here is optional. Okay, but it's a good practice lah to start. Compared to yang bawah ni, yang bawah ni hanya 2 input tapi selector 2 bit. Dalam kes ni, this will create unwanted latches. Okay, unwanted latches, and to avoid that, you need to have default statement here. Right? Either you have default statement here, ataupun you modify selector ni become 1 bit. Okay, alright. So I think this is actually a summary lah between if else, when to use if else, and then actually the pros and cons lah between if else. If else also case statement. Okay, ini example 4-to-1 multiplexer using case statement and the other one using if else. You can try on your own and try to synthesize and see the logic ataupun the RTL sama ataupun tak, and then you try to do the technology, okay, technology view, and then you check in terms of area utilized in the FPGA. So untuk check the area utilized in the FPGA, we run the technology. Okay, run the technology view. Ini banyak student tanya lah. So different between RTL and technology. So RTL is more on the design side. It's not related to your targeted FPGA device apa nama semua kan. But for the technology, it's related to your targeted FPGA, and then it will tells you the exact logic cell that used in your design. Okay. Ini penting macam dalam lab report you kena explain lebih kompleks lah, tapi a bit more. Okay, so we discuss that. Okay, saya nak cover satu lagi benda yang important. I think most of you tanya last week, which is on okay, blocking and non-blocking. So if you remember, sometimes we see this sign, always add, and then you do you nampak assignment macam ni, and then you nampak assignment macam ni. So this is actually what we call as blocking. Okay, and this is actually non-blocking. Cara you nak kenal dia, senang saja. Bila you nampak tanda macam ni, maksudnya dia suruh sila. Sila allow you to mean that it's non-blocking. Okay, but for continuous assignment, we don't use non-blocking, we use blocking. Continuous assignment tu yang assign tu lah. Okay. Contoh yang ada di sini kot. Okay, ini contoh blocking. Okay, and satu lagi non-blocking. So it gives you different at the end of the result. Okay. Contoh dalam ni. So the point here is actually for blocking, it evaluate, okay, evaluate A or B and result it update to X, okay, immediately, and that's why I see the put immediate evaluation. Sama macam line number 2 ni, evaluate this statement and then it assign immediately. Okay, same to line number 3. But if you use non-blocking, it will defer the assignment of X, okay, assignment of Y, and assignment of Z until finish of the until all the right hand side has been evaluated. Maksudnya dalam kes ni all the right hand side semua ni lah. Baru habis, nanti yang habis ni baru dia akan update X, Y, and Z. So that's actually the difference between the blocking and non-blocking. Application of usage you may explore on your own lah. You boleh cuba and then tengok what's actually the corresponding pointing output. Right? I think ada example kot. Okay, ini elaboration lah, explanation ya. Okay, ada example here. You explore this. Okay, for example, A equal to B and B equal to A, and we have this. This is actually the what we call the answer lah in the form of timing diagram. Nothing happen lah kalau you tengok sini sebab dia immediate. A equal to B, B equal to A, they immediately update because we have multiple ataupun 2 concurrent always block, so execution dia akan jadi serentak. Okay, this is another example for okay, for non-blocking. Non-blocking different. So you explore this, okay, see the difference. So actually we have the same lah, 2 concurrent always block, tapi the different adalah so disebabkan dia defer assignment tu, so we see the changes lah, see the output, right? The rest you read on your own, baca sendiri lah ni, and then ada waveform di sini yang you boleh cuba explore lah. Okay, additional note given to you, you explore on your own. Okay, and then we also have PCA, continuous assignment, consider continuous assignment, and then delay control. We also have discussed this. Kalau pasal ini tanda hash ni adalah, contoh for example kita letak hash 10 kan, so maksudnya kita delay sebanyak 10 time unit. Okay, ini kita gunakan banyak dekat always at positive age and so on. Okay, the 2 don't worry. Okay, you can explore on your own. This is actually the explanation. Okay, ini example lah. So we use the hash 0, hash 100, and hash 95. So the output of this one, kalau you tengok ada di bawah ni, you boleh explore. Okay, we have also provide you with the answer lah. Okay, so untuk the first, clock equal to 0, clock 1 equal to 0, nampak tak clock 1 equal to 0. Okay, for how long? 100 time unit, and that's why you see slow until 100 time unit. Okay, and then clock 2 at the same time equal to 1, and that's why you see clock 2 equal to 1. Okay, and after 100, clock 1 equal to 1, the high. Okay, and clock 2 equal to 0. For how long? Follow ini. Actually, explanation of this one. Explanation of this one. Alright. Event control, we also have discussed. Okay. Name event, we skip first. And explore on your own. And then, I think this one also. Extra lah. This is actually extra for you to explore. Right? Explore control. So please read this one. Explore. Okay, for example, how do we create a clock? So we define using parameter. So I saw some of you use parameter in lab number 1 assessment. So good, okay. So we define, normally we use parameter to define. So half cycle we define as 100. So after this line, we just use half cycle. So it means that we use equal to 100 lah. So this is also 100. Okay. And we use forever to generate clock. So in this case, half cycle equal to 100. So clock equal to inverted clock. So the clock period T equal to berapa? 200 200. Because the first, because the delay here is half clock, half cycle. So 100, so another half 100 for inverted version. So initial value of the clock 0 means that your clock equal to 0 for 100 and then 1. Okay, and then 0 and 1 and so on. So the total here is actually the T, which is 200. Okay, so by this time, you should be able to predict the waveform. All right, I think that's all. Okay, we have finished already. Ada soalan before we end our lecture? Any question? So next week, holiday, a week after next week, we come for the what we call the invited lecture, and then during the 1 hour lecture, we will continue or finish on FSM. Okay, all right. Any question before we end?